Hey guys, welcome back to Unreal Labs. I'm glad to be back. It's been a while. Today we're going to cover an IPsec tunnel. I figured that would be a good way to jump back into videos. So I've got the Cisco Virl lab with two Cisco routers, a couple workstations. We're going to create a tunnel between those and encrypt some traffic. So let's get going. All right, guys, we're logged into the Virl lab here. So, like I was saying before, we have R1 and R2. We're going to use this, I'm calling external network here, which is really, we're just going to kind of fake the internet. The IP scheme I put in there was just a 10/24. So we'll do a 1 and a 2. We have 3 desktops, desktop 0, 1, and 2, each in a different subnet here. So 192.168. A 172.16.1 and a 172.16.10, all on /24. So I'm going to encrypt the traffic between this on this IPsec lab. I'm going to encrypt the traffic between desktop 0 and desktop 1, or vice versa, desktop 1 to desktop 0. Now, traffic from desktop 0 to desktop 2 is just going to be unencrypted. Same goes for desktop 1 to desktop 2. So we're going to, like I said, I wrote that article at Unreal-Labs. I'll leave that in the description. You guys can reference the documentation if you need the commands again. So you don't have to necessarily worry about if you're trying to follow along. You can definitely reference that article, and you'll see what I'm putting in here. Let's just go to that article real quick, just so you guys can see it. So the steps that we're gonna be configuring. So I need to do some basic configuration of the routers. I need to get the IP connectivity so they're talking to each other. We've got to configure an ISAKIM policy. So this is the start of phase 1 here, and I've got some, like I said, I'm not going to go into all the descriptions here, but this is the command set we're going to be dumping in there. We're going to have to configure the ISAKIM key. So there's I think there's 6 or 7 steps here. So we're going to do a crypto ISAKIM key, and then we're going to choose a, hopefully you guys, if it's production, you're choosing a fairly long paraphrase, and then the peer address would be, the routers between each other. So either 10.0 to 01 or 10.0.0.0.2. Then you're going to configure the IPsec transform set. So we're moving on to phase 2 of the IPsec tunnel. So we'll get that configured. We're going to create a crypto ACL, which is going to identify the traffic that's going to be encrypted, right? So like I was saying before, we're only going to encrypt from desktop 0 to desktop 1. We don't want to encrypt desktop 2 or that network, so that's where we'll set that up. We'll configure the crypto map, and we'll apply the settings from above into that map, even including the ACL that we'll want to use, and then we're going to apply that crypto map to the interface on R1 and R2. So we've got to do this configuration on both routers. And then there's some verification steps we'll go at the end. I might just be doing some Wireshark just to show you kind of what the traffic's looking like. That's the best way to, and like I said, this Virl's pretty neat. GNS3 definitely can do Wireshark totally. Yeah, this makes it pretty easy. I'm actually really liking this Virl setup. So yeah, let's like I said, that's unreal-labs.com. And let's jump in, huh? So I've got the lab going. Switch back over here on the right screen. All right, so I'm going to jump into router 1, and I'm going to get this side first, and then I'll get router 2. I've already configured gig 0, 1 on router 1 and 2 and 3, so all the workstation connectivity just to their local subnet here is set up. So let's jump in here. So where are we at? We're on router 1. That's where we want to be. So let's show run here real quick. I haven't saved any configurations yet. Yeah, as you can see, so there's gig 00. Nothing's on it, but gig 01 is working, so, or is up at least, or configured. So let's dump into gig 00. And that's going to be 10.0.0.1, just the IP. This would be, let's just say, like your WAN IP from your ISP, so no shut. And then I do want to create an IP route. Actually, that finish here, IP route. And I'm just going to make a default route to 10.0.0.2. So I want to forward all traffic from router 1 to router 2, and I'm going to do the same thing with router 2 to router 1. Just so I have connectivity. We'll test that here in a second. And we'll jump over to R2 here and show run. And as you can see that, so gig 00 needs to be configured, but 1 and 2 have been. So config T, interface gig 00, IP address 10, that's going to be 2. And we'll no shut that, so it brings that up. Should see that showing up here in a second. All right, that looks good. And I'm going to do the same thing. I need an IP route, I need a default route. The 1. So you guys can see that. So our local network's connected here, right? And then our gateway of last resort is 1. All right. So let's jump over, actually, let's minimize these, and let's get over to desktop 1, or desktop 0, I mean, and let's just test connectivity. So let's just test its default gateway, which would be 1.1. Let me move over to this just so you guys can see the refresher screen here. So I'm just testing from desktop 0 to its default gateway, so just that 1. And then we'll try the desktop 1 and desktop 2 here. Actually, desktop 2 is .2. Or desktop 1, excuse me. And then 10.2. All right, our connectivity looks awesome. So let's jump into the configuration on R1. Or actually, that's our Cisco Virl lab. That's the box. Let's reattach this real quick. Attach that. I love MOBA Xterm. Such a great. All right, so we're on R1. I'm going to pause this real quick. I'm going to make the fonts a little bit bigger. Give me 1 sec. I'll be right back. All right, so I made the fonts to 20. I'm hoping you guys can see that. So let's jump in. So we've got, like I said, IP connectivity's been established. We've got IPs in the right spots. So we're ready to move forward with the IPSec configuration. So we're going to start with phase 1 of this. So I hope that didn't pause on you guys, but yeah, let's jump in. All right, so we're back to config T. Sorry about that. I was on the wrong window. So we'll get to configuration terminal, and then it's crypto, ISACamp, there we go. And if you hit question mark, like you said, you've got a ton of options here. So we're going to do policy 10, and we could do policy 100 if we want, but I'm just referencing the article I wrote so you guys can follow along. And then we're going to choose our encryption, which is going to be, like I said, we have 3 options, but in the article we're using AES, and then hash, like the article is saying, it's SHA, authentication, and we're going to use, I'm going to question mark that so you guys can see there's options there. We're going to use pre-share for a pre-shared key, and then root, we're going to be choosing Diffie-Hellman group 2. So that'll be the one we're choosing. We have our life 3600. Actually, I'll do options here. So yeah, 3600 in seconds. So 60 minutes. And now we're going to jump into configuring our ISACamp key. So I'm going to exit here from that position, and then we're going to go crypto, ISACamp, and then I'll hit question so you can see there's a lot of options. So we're going to use key, and I'm just going to use hit question mark on that. I'm just going to put an unencrypted clear text in here right now. It's just going to be test. You're going to want, if this is production, you're going to want an encrypted key that's fairly long. So FYI, this is just a lab. And then the address on this is going to be the peer address of router 2, or the WAN address of gig 2, right? So we're going to be 10.0.0.2. That's the peer address we're going to want to set up. So let's jump back over here, 10.0.0.2. And that should set up, so that finishes actually phase 1 of this configuration. So let's jump into the transform set. So crypto IPSec, there's options there. I always forget to question mark for you guys. So there's IPSec, transform, question mark. We'll see transform set. And then I'm going to name it, if you question mark that, it's looking for a word there. So I'm just going to name it my set, and I'll use that on both routers. And then if we hit question mark again, it's going to ask us for the transform set. We're going to do ESP AES. And then we're going to use ESP. I think it's SHA. What did I have on there? SHA, HMAC. Probably mispronouncing some stuff, but that's okay because I'm terrible at that. So we're going to exit that, and now we're going to configure our ACL to define the encrypted traffic that's going to be going through. So access list, and we have some options there. I'm going to use an extended, so 100. We're going to permit, and question mark, we have a bunch of options. We're going to do IP, right? And then we're going to use the source. So we're on router 1. We're on router 1 here, so I want to do the source is the 192.168.1.0, and then the destination is going to be this 172.16.1.0. Let's go back over here, make sure we're on the right window, so don't accidentally pause the video. Actually, whoops, I actually screwed up there. I hope you guys caught that, if you guys are familiar with. So we need wildcard bits on this one for the ACL. So 00255. Question mark, now it's destination, so 172.16.1.0, and then the wildcards are just a subnet mask, right? So 0.0.0.255, and that sets up our ACL. And now we're going to be doing our crypto map, and I'm going to, like I said, it's going to have a name here, so I'm just going to call it my map, just so I remember it. Question mark, there's some sequence of that map, so we're just going to start at 10, and IPSec, hit question mark so you can see the other options here. IPSec IM, and then we're going to set a peer address, which is going to be 10.0.0.2, and we're going to set our transform set, and that was that my set I chose up in the top of the configuration. And then we're going to need to match the traffic, right? We want to identify the traffic, so match address, and that's going to be access list 100, that access list 100 we just created. We'll exit this configuration here, and then we're going to apply that crypto map to an interface, and the interface we're going to want to do is gig 00, right? That outside interface. So interface gig 00, and it's just crypto, as you can see, map, and then my map, which is what we defined up top here when we first started. All right, so that looks good. So now I need to duplicate that on router 2. I'm not going to have you guys, I don't want you guys to have to watch the whole thing over again. So I'm going to duplicate that on R2 real quick. I'll be right back. I'll show you the configuration after I'm done with it so you guys can see the little changes I have. It's just really, we're doing a mirror copy, except we're changing the peers to reflect the R1 interface. I'll pause this and then we'll be right back. All right, we're back. So here, I'm just going to scroll up on the configuration. So like I said, I just started the same configuration, just duplicated that same configuration onto router 2. I just made some changes, right? Because I wanted to reference 10.0.0.1 for my peer since I'm on R2. And the other change that I wanted to make, so also the key is still test. So I wanted to use I want to match keys, right? Because I need to agree on that. And then the the access list is a little different. So instead of 192.168.1 to begin with, right, as the source, since we're coming from the 172.16.1, that's going to be our source, and our destination is going to be 192.168, right? So that was a change there. And then in our crypto map, the excuse me, my peer is 10.0.0.1. And then I match the same access list because that's the access list I created. I like to keep those kind of the same if I control both ends of the tunnel. Sometimes you don't. Sometimes you have a customer network where, you know, they're configuring one end and you're configuring the other end. You do have to agree on things, but configurations can be a little different, which then can cause problems. So, and like I said, the configuration's going. So what I really want to show now is, if we jump back over to the Virl lab, I am going to start a packet capture here. And I'm pretending like I'm actually packet capturing this line out on the internet. And I'm going to do a ping from desktop 0 to desktop 1. Actually, let's do a ping first to desktop 0 to desktop 2. And we can do that in Virl here. Let me clear this. And you can download it to a local instance of Wireshark if you want. But I'm going to start that. And we'll start seeing some traffic actually come across this packet capture. And this is just between these two devices here. And if we switch over, I have a terminal window, SSH connection to desktop 0. I'm just going to do a ping to desktop 2. So that was 172.16.10.2. I'm going to fire that ping off. Clear the traffic here so you guys can see that ping rolling. And so you're seeing actually the source, which is 172.16.10.2. Or well, I started actually on 1, so it's actually there's sequences off for me. Sorry, 192.168.1.2, and at the destination, and it's ICMP is the protocol. And so you're seeing it actually unencrypted right now as it's going across this network. So that traffic's coming up here. That's all unencrypted, and we're capturing it right here. So I'm going to get on desktop 0. I'm going to stop that ping, and I'm going to do a ping all the way to desktop 1. And I want to show you kind of what happens and what we should be seeing. So let's stop this. And we'll go 172.6.1.2. We'll get that ping going. And we'll start the capture here. And you'll notice the traffic is now different, right? So we're not seeing the source from 192.168. We're actually seeing the source is 10.0.0.1. The destination's 10.0.0.2. So we're only seeing this right between these two interfaces. And then if you look at it, the protocol is ESP. So these are encrypted. These are encrypted traffic. I'll let it, I think it's 60, right? Yeah, I think it's set to 60. So if I click on this, let's download it. Open that up. And we'll open it to a local Wireshark. And we can see that capture that's going on. Shoot, you guys didn't see any of that. Darn it. Well, there goes my surprise. But we start the capture again, so you guys can actually see it. So what I was talking about was the source was 10.0.0.1 and 10.0.0.2. Sorry about that. And the protocol is ESP. It's hard for me to get these windows. I'm not very good at YouTubing, I guess. Get better, especially with your guys' suggestions. So that's been super helpful. We start that capture again so you guys can see it. So we're only actually seeing the encryption part of this. We're not actually seeing like ICMP in the source, right? So we know our IPSec tunnel is actually functioning, and we're getting replies back. So we know we have communication. So we really have configured successful IPSec tunnel between these two routers. So let's I'm going to pause real quick and we'll set up some verification just so you guys can see what the tunnel looks like when it's up inside the router. So let me pause and I'll be right back. And so we're on router 1, and the command I'm running here is just show crypto ISACamp SA. And what that's going to show us here, hopefully, is the status is active, which is what we want. And right now it's in an idle state, but we can see there's the destination and then the source. So the source, we are on router 1. And the next command I'm using, if it was IP6, you would see something there too. Or it actually, you wouldn't see anything in the IP4, it'd be on under IP6, which we didn't do. IP version 6, I'm terrible at. But here's so gig interface. So the other command is show crypto IPSec SA, and this is in the article if you guys want to reference this. So if you're troubleshooting like a IPSec tunnel that isn't coming up, these are the commands you're going to want to see. And currently, right now, we're actually showing packets. In caps is 129. So, and then the decaps are 129. So we're not like having in caps happening. That would be a sign that something's wrong, right? And then your decaps are, you just have nothing coming back. So you'd get timeouts, which means that something's not matching up. You can see like our plain text MTU, path MTU is 1500. Lots of good information in here. You could also run, if you wanted a debug on this, let's pull up that command here. Let me pause and we'll do a debug. All right, so I'm gonna turn on debugging crypto ISACamp, if I can spell, and then I'm gonna debug. Now, if you're doing this in production, like, you're gonna be careful. This is just lab, so all that's on. Now I'm gonna actually clear the crypto ISACamp out. So I'm hoping to start, like, actually see the traffic come back. So let's see what happens here. There we go. So now we're seeing some debugs rolling through. It deleted it, right? It wiped that that current tunnel out. And then I'm wondering if let's show crypto IPSec SA. And yeah, we have active. So that looks good. Our tunnel is back up. If we fire over to desktop 0, we should be able to still ping. Let's clear that again real quick so we can show. Man, it comes up super fast. Slab. I was hoping to kind of show, like, if it more delayed time. But like I said, definitely look at these show commands, because this is where it's going to be showing like your source and your remote networks, and then you can duplicate this if you control both ends of the tunnel, like on R2. So hopefully if you had local access, you could see that. Let's show crypto IPSec SA. So this is just the reverse, right? 172.16 as our local identifier, and then remote, and then our in caps and decaps or decrypts are good. So our packets are getting encrypted and they're getting decrypted. But yeah, so short video. I'm a super fan of the Cisco Virl environment. Let me pull that lab back up. It's kind of winning me over. So hopefully I'll have some more labs in this here soon. I love my physical gear, but this is kind of fun. So it's got a lot of options. This is, like I said, a web interface off my browser to the lab. Just like GNS3 has a very similar thing, but this seems to be pretty smooth. It just requires some horsepower. This machine is 32 gigs of RAM. It's really not enough. As you can see, like, memory, I'm at 20%, and I'm just running this little lab here with only 5 nodes. The license I bought was a 20 node license, so if I put 20 nodes on this, I'm probably struggling. I can expand this disk out. It is running on an SSD. So I could expand that out if I wanted to a little bit. The CPU, this is an i7. I think it's actually it's an older i7 too. I just had to pull a bone part machine out that I had. I think it's like a 5th gen i7, so it's doing fairly good. It's just not going to support really a 20 node lab unless I dump this up to like 64 gigs of RAM. Even then, I'm not quite sure, but we'll keep on going with some videos and see how this works. I feel like we're gonna get good use out of this at Unreal. So, like I said, please feel free to go to my website, unreal-labs.com. There's other tutorials, other articles out there. I appreciate you guys listening. I apologize for not being around for a month. Just been busy with work, as you guys are probably the same, especially at the end of the year. Then again, thanks again. I appreciate your time. I will talk to you soon.